As a third problem, I prepared a problem where we can find all four reactions N, V, T, M, and the problem looks like this. So in this problem, I'm not gonna solve the problem like in numbers. I will just give you the conceptual way to approach this kind of problem. So problem asks us to solve the maximum shearing stress and maximum principal stress at K point and H point. And this problem has interesting loading. So it has a cylindrical cantilever beam. At the end of the cantilever beam, we have this rigid rod that is attached to the end of this cylindrical cantilever beam. And at the end of this rod, we have two forces, P2 that is vertically upward, and P1 that's longitudinal, but like in a compressive direction. So out of P1 and P2, we can generate all kinds of different reactions. So let's just start from the P2. So and we're gonna consider a cross-sectional area including K and H. So in the cross-sectional area including K and H, maybe H is here and K is here. So due to P2, we have of course the vertical force V that is if we consider the centroid reactions, the V is upward, and P2 somehow induces like this rotating torsion, and the size of torsion T is the same as A times P2. Okay, so that's the torque with respect to longitudinal axis. Now, and this P2, because you are considering this cross section, there is distance from P2 and that surface which is B. So there is a moment. This moment is in this direction. In the size of B times P2. Okay, so there is two torque AP2 and BP2, with respect to the centroid, and there is one force V, which is P2. And there is contribution from P1, and P1 has two contributions. First, it has normal stress, P1, along that direction, and we have also moment M prime. This P1 and B is due to the distance between centroid to P1 A. So A times P1 is working as M prime. Okay, so this M prime, actually I put the colors the same as the P1, and the colors with TVM is same as P2. So the size of M prime is the same as A times P1. Okay, so what you can see here is, by applying P1 and P2 at the tip of this rod attached to the end of the cylindrical bar, we have 5 reactions, T, V, M, and M prime. Okay, so this combines all the reactions you can think about. So if you consider infinitesimal volume at K point and infinitesimal volume at H point, we have combined the normal and shear stress. So let's consider H point first. At H point, what kind of reaction do we have? At H point, there is no reactions due to stress due to M prime, because M prime goes through this H, but there is normal stress due to M, and there is shear stress due to T, and there is normal stress due to N. Okay, and there is no shear stress due to V, because according to this vertical stress V at the top, there is no contribution. So that's the normal stress and shear stress you can find out of this 5 reaction force. Now let's consider K point. About K point, we have normal stress from N and the normal stress from M prime, but there is no normal stress due to M, because M goes through this K volume, and there is large shear stress due to B, because this is at the centroid position, and the Q becomes really large, so you're gonna expect the shear stress at K point, and there is also shear stress due to T. Okay, so you can identify the reactions that cause either normal stress and shear stress at K point and H point. And if we clearly summarize, you can draw these free body diagrams. Okay, and for each component, sigma and tau, you combine the reaction from different reactions, and for sigma and tau, you combine and sum up the contribution from different reactions, and after identifying sigma and tau, what you do is you do apply the Mohr circle for 2D and try to obtain maximum normal stress and maximum shearing stress. And if the problem asks full three-dimensional Mohr circle analysis, you do three-dimensional Mohr circle analysis and find the maximum shearing stress and principal stresses, and by comparing that with normal strengths and shear strengths of the material of that structure, then you can say whether the structure is reliable or not. Okay, so that's how to approach the problem combining all four reactions in different directions. Okay, so here let me stop the recording for the third example problem.